All right, today let me remind you what vertex form looks like.
Is that the one with the Y?
Yes. It's the one with parentheses.
And there's like the X plus A with the H squared.
Usually we do X minus H because the H is the backwards thing. X minus H, we need it squared to make it a parabola.
And then plus the B. Or whatever it's like.
Okay. There's also an A out front to control the stretch. That's the Y, not the Y-intercept, but the Y-coordinate of the vertex. In fact, the vertex then is H comma K. Because minus H would mean right H, plus K would mean up K. So we like the vertex form. Because you can just immediately see the vertex, right? Like that's why we like it. It's go to the vertex, do the 1, 1, 2, 4 stuff, like super easy. It's still not bad if it stretches. Standard form, that's the one that looks like ax squared plus bx plus c. What do you do to have to graph that one?
Solve it.
What's the x coordinate of the vertex?
Negative B over 2.
Negative b over 2a, and then you plug it in. That gets you a point.
Which is the half it squared? Is that complete the square?
That's complete the square. What we're going to do today, though, rather than go this route, which isn't terrible, but it's so nice in vertex form, we're going to talk about how to get it from standard into vertex form. And that looks like a perfect square, which means we should complete the square. What did you say, Ryan? I think you may be onto a different method there.
How we just get the H and K.
Okay, so one method, the method we're not going to do, but it's a valid method. Ryan says find H and K this way, because that would be H, right? That's the x coordinate of the vertex. Plug it in to get K, and then write this. And your A would be the same. That would work. We don't want to do it that way.
Isn't that like the easier one?
I don't know. Y equals x squared minus 4x plus 9. And I would like there to be a perfect square in there. So let's move the 9. I'm not going to move the 9 to the other side, because then it wouldn't be vertex form. But I am going to sort of move it out of the way. No, so it's still plus 9, right? I didn't move it to the other side. I just wrote it a little bit further out to make room to complete the square in here.
Is that where we're going to half it?
Yep, that's where we're going to half it, square it, add it. So half it gets us negative 2. And when we square it, we get plus 4. Now here's where things are a little bit different from what we did last time. When we were solving using complete the square, we add 4 to one side, which means we need to add 4 to the other side. But here I want everything on one side because I want y equals something. So I can't just go sticking plus 4 on the side. That's not like fair, legal, not right. So what would like counter the plus 4 that I wrote? I could subtract 4.
So then the 4 would just...
So, yeah, those 4s would cancel, and then you'd be right back where you started. But the point is, I want to turn this. Now this is a perfect square. Remember, it factors with the minus 2 every time. Oh, there it is. There's vertex form.
Wait, what?
Okay, if you want the 4s to cancel out, great, but then you're right back to where you started. You don't have vertex form. You have standard form. I put the plus 4 on there to make this part a perfect square. But if I put a plus 4, I also have to put a minus 4.
I thought you had to like put the 9 on the other side and make it negative.
Okay, if we're solving, then yes, we move it over. But this time I want it, remember my goal is to make it look like a times x minus h squared plus k. So I don't want anything on the other side with y. So rather than moving it over, I just sort of move it out of the way.
I understand now. Yeah, I don't get it.
You're okay with the half? You're okay with that part, right? Like half it, square it, add it, make it a perfect square. But if I put a plus 4 there, I either need to add 4 to the other side, but I'm trying to keep y by itself, so I don't want to do that. Or I can minus 4, because that doesn't change the equation, right? Plus 4, minus 4. They would cancel out.
Wait, but then how does the 5 come out of that?
Well, I combine the 9 and the 4 to get the 5. Right? This became this.
It becomes basically 2 different equations.
And this becomes this. Is that better?
Okay. That makes sense.
Just should have used the highlighters. Let's do another one. Two x squared minus 4x minus 3. What do you remember about complete the square? I hope you remembered it because it was the first question on the. Yes, x has that coefficient on x has to be 1. But I don't want to divide by 2 because I want y equals. So let's factor it out. So x squared minus 2x. I don't even want to worry about the 3, right? The minus 3 I'm just moving out to the end, leaving him alone. Right? I don't want to move it over because I want to keep y by itself. Feels like cheating? I mean, completely legal. It's just feels weird, but I'm trying to turn this part into a perfect square. So half it, square it, add it. So b over 2 is negative 1. So I write plus 1 to make a perfect square. Now, be careful though. I wrote plus 1, but it's on the inside. So what did I really just add to this problem? I added 2 because there's a 2 out front. I wrote plus 1, but because it's on the inside, I really added 2. So how do I balance that out here? Subtract 2. Add negative 2. Yes.
Wait, why did you subtract 2?
Because right here I added, it looks like it says plus 1, but it's really an add 2. Because there's a 2 out front, right? That's what that 2 out front does. So if I'm going to add 2 on one side, I better subtract 2 on the same side. Or add 2 to the other side, but I don't want to do that. I want to keep y by itself. Okay, so for Cooper's benefit here, the pink stuff becomes.
I kind of got it now. It's like it becomes
What?
almost 2 separate equations where it's like you factor out the first part and then the second part just goes in.
So what does my pink part become if I want to rewrite that? X minus 1 squared.
And then minus 5.
And then minus 5. And so then I've got my vertex at 1, negative 5. And I could do the 1, 1, 2, 4 stuff, although it would be multiplied by 2, so it'd be stretched out, but that's old news. So we're still doing half it, square it, add it, but we got to be super careful with that 2 last time. All right, let's do number 3 on the worksheet. What should I do first on number 3? Factor out a negative 2. So x squared plus 16x. And then the minus 118, that's like, get out of my way. Like, Usually get out of my way means move to the other side. Now we're just like, just step to the back of the line, please. Like, get out of here.
Wait, it would still be minus one.
I'm not going to divide that by 2. I'm not factoring a 2 out of that. Because he's out of the way. He's special. Better be careful. I'm recording. I can't say anything too bad. Half it, square it, add it. So half it, I get 8. Square it, I get 64. Okay, so I wrote plus 64, but what did I really do right there? I subtracted 128, so I need to add 128.
Okay.
Yeah? So I wrote plus 64, but that meant I subtracted 128, which now means I need to add 128.
The negative is no effect on it.
No, it does have an effect on it.
That's why we added.
That's why we add it. Usually we subtract it. So my pink part, x plus 8 squared. My green part just becomes plus 10. Directions. Use the information to write the vertex form of each parabola. Oh, it didn't even ask for vertex, so we're done. So get C out of the way, not to the other side this time, just out of the way. Do your half it, square it, add it. But be super careful about the number you put in there. Make sure you counter it elsewhere. So counter it meaning you got to consider what you factored out. All right, your assignment is the rest of them. You got 20 minutes to work on it.